Welcome. So in this video, I want to look at the limit of a function that is defined piecewise. Specifically, this function is f of x equals x squared plus 3x minus 1 if x is strictly less than 0, and x plus 1 if x is greater or equal to 0. Now, I want to look at the limit of this function as x approaches 0. Now, you see, at 0, the rule for f changes. And this typically translates into a graph that is significantly different on either side of 0. So you can see I have a parabola if the values of x are less than 0, and a straight line if the values of x are greater than 0. Now, as we approach 0, we need to look at the limit coming from the left and coming from the right, because once again the rule for f changes at 0. Now graphically, this means, for instance, that if we approach 0 coming from the right, okay, the values of p here correspond to points that lie on the graph of f. So I get x and f of x here for my y coordinate. So what I want to look at for the limit is the y value for my point as this value here, the x value, approaches 0. Now I will approach 0 coming from the right, which means that I want to have positive values here. So I will move my slider and make those values as close as I can to 0 and try to see what those y values are. So this graphically is a way of illustrating what a limit coming from the right might be. So as I move this slider, too much. If I move this slider coming from the right, as you can see, I get y values that are getting closer and closer to, can you guess? Here the value is 1.1, but that's because I'm at 0.1. I could get even closer to 0. If I get as close as I want to 0, I will get a y value that will be as close as I want to the y value of this point, which is 0, 1. So the limit coming from the right is 1. Similarly, if I choose x values that are less than 0, and I look at the y values, as I get closer and closer to 0, the y values are getting closer and closer to, can you guess? It would be minus 1, which would be the y coordinate of this empty dot. Just to finish, notice that I have an empty dot here because at 0 the function value isn't defined by this expression, it's defined by the expression x plus 1. So which means that I have a full dot here, because if I replace x by 0, I get 0 plus 1, and that's the function value at 0, which means I have a full dot here and an empty dot here, there. However, the function value at 0 does not influence the value of the limit at all. I could have two empty dots, and the analysis I would be doing would be exactly the same. So to recap, approaching from the right, I approach values that are getting closer and closer to 1, which is the y coordinate of this point. Approaching 0 coming from the left, we get values that are closer and closer to the y coordinate of this empty dot, which is minus 1. So minus 1 is the left-hand limit, and 1 is the right-hand limit. So now that we've looked at a graphical interpretation of the right-hand and left-hand limit, I want to look at an algebraic way of looking at it. So if I have my function defined piecewise and I'm interested in looking at the limit of f of x as x approaches 0, because the rule for f changes at 0, I should be looking at the case where x approaches 0 coming from the right and from the left separately. So let's first start with a limit coming from the right. So I want to look at the limit as x approaches 0 with values of x that are larger than 0. So I'll put a little plus here of f of x. Now the rule for f of x is x squared plus 3x minus 1. X plus 1 in that case. because this is what happens when x is greater than 0. So approaching 0 coming from the right. I can replace f now by x plus 1 because that's a rule when values of x are larger than 0. And this limit is very simple because if I replace x by 0, I get what those values are approaching. So I can replace x by 0 plus 1, and the limit is 1, which in the previous graph was the y coordinate of the full dot. And now if I look at the limit as we approach 0 coming from the left, well, the rule in that case is x squared plus 3x minus 1. And in that case, once again, I can easily evaluate this limit by replacing x by 0. So we get 0 plus 0 minus 1 equals minus 1. So the value of the left hand limit is minus 1, and that's the y coordinate of the empty dot in the previous graph. Overall, because those two slighted limits are not equal, the limit of f of x as we approach 0 from either side does not exist, because on one side it's 1 and on the other side it's minus 1. So we could write does not exist. Thank you.